Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the area of this circle. In the second question, we'll find out the area of this trapezoid ABCD. So we'll start with the first question. In the drawing we have a circle, and this is the common extreme point P. From this common extreme point P, we have two tangents to this circle, tangent PA and tangent PB. In addition, we have the right angle ACP. Side CP of the right angle ACP is equal to 4 units in its length. Here, line segment BC equals to 1 unit. And our mission is to find out the area of this circle. So first of all, we can implement here rule 2. So let's click on rule 2. According to rule 2, the lengths of two tangents from a common extreme point to a circle are equal. So in the drawing we have a circle, and this is the common extreme point P. From this common extreme point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. Why? Because in our drawing, we have the common extreme point P. From this common extreme point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB. So write it down. Given us a question that the length of this tangent PB is 4 plus 1, that is 5. So PB equals to 5. So write it down here. That PB equals to 5 according to what is given us the question. And for this equation, PA equals to PB equals to 5. We derive that PA is also equal to 5 units in its length. And PA equals to 5. This is line segment P8 is equal to 5 units in its length. In the next step, I'll copy the right angle ACP in a new page, and we will implement the Pythagoras theorem on this right angle, triangle ACP. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to the sum of the surface. Is equal to the sum of the squares of the perpendicular. So actually, this is the right triangle ACP that according to the original drawing, according to the Pythagoras theorem, in this right triangle ACP, AP squared, that is the square of the hypotenuse, is equal to AC squared plus CP squared. So I'll write it down. AP square, that is the square of the hypotenuse, is equal to AC square plus CP square. AP is 5, therefore AP square is 5 square, that is 25. And it is equals to AC square. AC is the missing side, so we leave it as it is. It is AC square plus CP square. CP is 4, therefore CP square is 4 square, that is 16. So in total we shall find out that 25 equals to AC square plus 16. Here we subtract 16 for this equation, and we get that AC square is equal to 25 plus 16 is 9. So AC square equals to 9. Here we take a root out of this equation, and finally get that AC is equal to the square root of 9, that is 3. So AC equals to 4 units in its length. This is the missing side AC, that equals to 4 units in its length. Here, AC equals to 4 units in its length. AC equals to 3. In the next step, we define the center of this circle. This point is point O. Likewise, we define the radius of this circle as x. In the next step, we will join points O and B together by a straight line. OB is the radius of this circle. This is equals to x according to our definition. Here we can implement rule 1. So repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the moment we have a circle, and this is tangent AB, that is tangent to the circle at this point, point M. In addition, we have the radius OM that is equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to this rule 1. So we can actually implement rule 1 in our drawing. Because in our drawing, we have the radius OB that is equals to x. The radius OB is drawn to point B, that is the point of tendency of tangent PB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent PB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means that this angle equals to 90 degrees according to rule 1. It's given us the question that PB is a tangent to this circle. So PB is a tangent, it is absolutely a straight line. So if you focus on the upper side of the straight line PB, it's point C here. So here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of PB at point C? We have this angle that is the right angle, plus this missing angle. In total they must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. According to rule 3. In the next step we will do a construction, that is to say from this point, point O, we will draw perpendicular on AC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. When you find the touching point of the perpendicular from point O and AC, this point is point E. By doing this construction, we can get quadrilateral DECB. Inside quadrilateral DECB, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, Therefore, this 4 pieces again must be equal to 90 degrees in size. So inside quadrilateral OECD we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a tesseract again, not a square. So we relate to quadrilateral OECD is a rectangle because it has 4 right angles. So I write it down. Quadrilateral OECD is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle OECB side OE must be equal to the opposite side BC. But BC is 1, therefore OE must be also equal to 1. Likewise, according to the sum rule, in the sum rectangle OECB, side OB must be equal to the opposite side EC. But OB is x, therefore EC must be also equal to x. What is the length for the missing line segment AE? On the drawing, it is very easy to see that AE in total equals to AC minus CC. Again, AC minus CC equals to AE. So I write it down. AE equals to AC minus EC. So AE equals to AC. AC is 3. EC is 3. Minus EC. EC is x. So in total, we found out that A equals to 3 minus x units in its length. In the next step, we will join points O and A together by a straight line. OA is of course the radius of this circle, that is equals to x, according to our definition. In the next step, I'm copying the right triangle OAE in a new page. And we implement the Pythagoras theorem on this right green triangle OAE. Here by PT is a abbreviation for Pythagoras theorem. So actually, this is the right triangle OAE that I got from the original drawing. According to the Pythagoras theorem, in this right triangle OAE, OA squared, that is the square of the hypotenuse, is equal to AE squared plus OE squared. So I write it down. OA squared, that is the square of the hypotenuse, is equal to AE squared plus OE squared. OA is x, therefore OA squared is x squared, and it is equal to AE squared. AE is 3 minus x, therefore AE squared is 3 minus x squared, plus OE squared. OE is 1, therefore OE squared is 1 squared, that is 1. So in total we found out that x squared equals to 3 minus x squared plus 1. Here we'll open the brackets on this side of the equation, and we get that x squared equals to 3 minus x squared. 3 minus x squared equals to 3 squared, that is 9. Plus x squared minus 2 times 3 times x, that is minus 6x plus 1. So here we have x squared on both sides of the equation, so x squared will get cancelled, After casting x squared, in this side of the equation we left in graphing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10, no 6x. So in total we have found out that 0 equals to 10 was 6x. Here we add 6x to this equation. And we get that 6x equals to 10. So here we divide this equation by 2 and finally get that 6x over 2 is 3x and it is equals to 10 over 2 is 5. So if we found out that 3x equals to 5, here we divide this equation by 3 and finally get that x equals to 5 over 3 units in its length. So if we found out that the radius x of this circle is equal to 5 over 3 units. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. So I write it down. The area of any circle is equal to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, we actually found out that the radius of our circle must be equal to pi x squared. So it is pi times x squared. X is 5 over 3, therefore x squared is 5 over 3 squared. So in total, we should find out that the area of our circle is equal to pi times 5 over 3 squared. So it is pi times 5 over 3 squared. 5 over 3 squared is 5 squared, that is 25, over 3 squared, that is 9. So in total, we found out that the area of this circle is equal to either 25 pi over 9 square units. So in terms of numbers, the area of this circle is equal to 8.727 square units. Repeat again, we have found out that the area of this circle is equal to either 25 pi over 9 square units. So in terms of numbers, the area of this circle is equal to 8.727 square units. So we finish with the first question. In the next step, I will present to you the second question and we will solve it. Our mission in this second question is to find out the area of this trapezoid ABCD. It is given us the question that AB equals to 16, AD equals to 17, BC equals to 25, and side DC of this trapezoid ABCD is equal to 44 units in its length. Again, our mission is to find out the area of this trapezoid ABCD. Actually, the area of any trapezoid is equal to the sum of its two parallel bases times the height over 2. Therefore, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases. The two parallel bases are AB and DC. So it is AB plus DC times the height. We define the height as h divided by 2. So in total, we found out that the area of trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AB plus DC times the height. Define the height as h, it is h times h divided by 2. The height h must create 90 degrees with the two parallel bases AD and DC. Okay, again, the area of trapezoid ABCD is equals to AB plus DC times h over 2. In order to find out the area of this trapezoid ABCD, we will do a construction. That is to say, from this point A, we will go perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and DC. This point is point E. We define the length of line 7 DE as X. We define the length of side AE as H. AE that equals to H, according to our definition, is one side of the right triangle AED, but AE is equal to H is also the height of the trapezoid ABCD. Why AE is the height of trapezoid ABCD? Because of the fact that AE is equals to H makes 90 degrees with the base DC. Therefore, H is also the height of trapezoid ABCD. So in the next step, I'll copy the right triangle AED in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle AED. Here by PT is a equation for Pythagoras theorem. So actually, this is the right triangle AED that is going from the original drawing according to the Pythagoras theorem. This right triangle AED, AD squared, that is the square of the hypotenuse, is equal to AE squared plus DE squared. So I'll write it down. AD squared, that is the square of the hypotenuse, is equal to AE squared plus DE squared. The hypotenuse AD equals to 17 units in its length, therefore AD squared is 17 squared, that is 289, and it is equals to AE squared. AE is H, therefore AE squared is H squared, plus DE squared. DE is X, therefore DE squared is X squared. So in total we shall find out that according to equation 1, H squared plus X squared equals to 289. In the next step, we will do another construction, that is to say, from this point B, we will go perpendicular on DC. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point F. We know that AB is parallel to DC. So those two angles, they are both located between the parallel lines AB and DC, and therefore they are both defined as an interior angles. And again, those two angles are defined as two angles because they are located between the parallel lines AB and DC. In addition, those two angles, they are both located on the right side of the straight line AE, and therefore they are also defined as one-sided angles. So in total, those two angles are both defined as one-sided interior angles. According to rule 16, the sum of two one-sided interior angles is equal to 180 degrees. So I repeat quickly on rule 16. According to rule 16, the sum of one-sided interior angles is equal to 180 degrees. So in the drawing, we have two lines. Line A is parallel to line B, and we have the third line I that cuts the two parallel lines A and B. Those two angles that are 4 and 5, they are both defined as one-sided interior angles, and therefore, according to this rule 16, the sum of those two angles is equal to 180 degrees. That is to say, angle 4 plus angle 5 equals to 180 degrees according to this rule 16. Likewise, those two angles, though, that is to say, angle 3 and angle 6, they are both defined as one-sided interior angles, and according to the same rule, this rule 16, the sum of those two angles is equal to 180 degrees. Here, angle 3 plus angle 6 is equal to 180 degrees. So we can actually implement rule 16 in our drawing. Why? Because in our drawing, so when I explain to you, those two angles are both defined as one-sided interior angles, and therefore according to rule 16, the sum of those two angles is equal to 180 degrees. So this is the missing angle BAE plus this angle, it is equal to 90 degrees. In total, the sum of those two angles must be equal to 180 degrees according to rule 16. So I'll write it down. The missing angle BAE plus the right angle, in total they must be equal to 180 degrees according to rule 16. Here we subtract 90 degrees from this equation, and we get that the missing angle BAE is equal to 180 degrees minus 90 degrees is 90 degrees. So this is the missing angle BAE that is equal to 90 degrees in its size according to rule 16. So inside quadrilateral ABFE we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ABFE we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be its rectangle plus a square. So we relate to quadrilateral ABFE is rectangle because it has 4 right angles. So write it down. This is quadrilateral ABFE. It is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle ABFE, side AB must be equal to the opposite side FE. But AB is 16, therefore FE must be also equal to 16 units in its length. Likewise, according to the same rule, in the same rectangle ABFE, side AE must be equal to the opposite side FB, but AE is 8, therefore FB must be also equal to 8 units in its length. What is the length of the missing line segment? Line segment FC. From the drawing it is very easy to see that FC equals to DC minus DE minus EF. Again, FC in total equals to DC minus DE minus EF. So I write it down. FC is equal to DC minus DE minus EF. So FC in total equals to DC, that is 44, minus DE, that is X, minus FE, that is 16. So in total FC equals to 44 minus 16 is 28 minus X. So FC equals to 28 minus X units in its length. In the next step, I will copy the right triangle BFC in the new page and will implement the Pythagoras theorem on this right triangle, triangle BFC. Here by PT is the formation for Pythagoras theorem. So finally, this is the right triangle BFC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle BFC, BC squared, that is the square of the hypotenuse, is equal to BF squared plus FC squared. So I write it down. This will be equation 2. So BC squared, that is the square of the hypotenuse, is equal to BF squared plus FC squared. The length of the hypotenuse BC is 25, therefore BC squared is 25 squared, that is 625, and it is equal to BF squared. BF is h, therefore BF squared is h squared. Plus FC squared. FC is 28 minus x, therefore FC squared is 28 minus x squared. So in total, we shall find out that according to equation 2, 625 equals to h squared plus 28 minus x squared. Here we open the brackets on this side of this equation, equation 2, and finally get that according to this equation 2, 625 is equal to h squared plus 28 minus x squared. 28 minus x squared equals to 28 squared, that is 874, plus x squared minus 2 times 28 times x, that is minus 56x. So in total we found out that according to equation 2, 625 equals to h squared plus 874 plus x squared minus 56x. Here we subtract 625 from this equation, equation 2. So in this side of the equation we left it nothing, that is to say 0. On the other side of the equation we have h squared plus x squared minus 56x, and 874 minus 625 is equal to 159. So in total we shall find out that according to this equation, equation 2, 0 equals to h squared plus x squared minus 56x plus 159. We only found out that according to equation 1, h squared plus x squared equals to 289. Therefore, we can substitute x squared plus x squared in this equation 2 by 289. We do it now and we get that 0 equals to x squared plus x squared is 289 minus 56x plus 159. Here we add 56x to this equation 2. And finally we get that 0 plus 56x is 56x. And it is equals to 289 plus 159. 289 plus 159 is 448. So here we divide this equation 2 by 56. And finally we get that x equals to 444 over 56 is 8. So x equals to 8 units in its length. We'll return back to equation 1. According to equation 1, x squared plus x squared is equal to 289. We just right now found out that x equals to 8. If x equals to 8, it means that x squared equals to y squared, that is 64. So now we can substitute x squared in this equation 1 by 64. We'll do it now and we get that x squared plus x squared, that is 64, is equal to 289. So here we subtract 64 from this equation 1, and finally get that according to this equation 1, x squared equals to 289 or 64 is 225. So we found out in total that according to equation 1, x squared equals to 225. So here we take a root out of this equation, and finally get that h equals to the square root of 225, that is actually the square root of 225 is 15. So we found out that the height from this trapezoid ABCD is 15 units. Our mission is to find out the area of this trapezoid ABCD. So I showed you that I found out that the area of trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AB plus DC times the height, that is h over 2. AB 16 plus DC is 44, the height edge is 15 divided by 2. So the area of trapezoid ABCD in total is equal to 16 plus 44 is 60. So this expression in total equals to 60 times 15 over 2. 60 over 2 is 30, so in total this expression equals to 30 times 15. 30 times 15 is 450. In total, if I found out the area of trapezoid ABCD is equal to 450 square units. Repeat again, if I found out that the area of this trapezoid ABCD is equal to 450 square units. So finish with the second question. The next step, I'll summarize the lecture. We'll start with the first question, of course. Our mission in the first question is to find out the area of this circle. So in the drawing we have a circle, and this is the current standpoint point P. From this current standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. In addition, we have the right angle ACP. Angle ACP equals to 90 degrees in its size. Side CP, the triangle ACP equals to 4 units. And this is right side BC, this is equals to 1 unit in its length. Again, our mission is to find out the area of this circle. So first of all, we implemented rule 2 in our drawing. That is to say, from this current standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB. So PA equals to PB according to rule 2. But it is given as the question that PB in total equals to 1 plus 4, that is 5. So we can write here that PB equals to 5, and from this equation PA equals to PB equals to 5, we will derive that PA is also equals to 5 units in its length. Here PA equals to 5. In the next step, I could be the right angle ACP in your page and implemented the Pythagoras theorem in this right angle triangle ACP. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to the sum of the slopes of the perpendiculars. So actually, this is the right triangle ACP, this is according to the original drawing. So in this right triangle ACP, according to the Pythagoras theorem, AP square, that is the square of the hypotenuse, is equal to AC square plus CP square. AP is 5, therefore AP square is 5 squared, that is 25. And it is equal to AC square. AC is the missing side, so we leave it as it is, plus CP square. CP is 4, therefore CP square is 4 squared, that is 16. So in total, we found out that 25 equals to AC square plus 16. Here, subtracting 16 from this equation, and finally found out that AC square equals to 25 minus 16 is 9. So AC square equals to 9. Here we took a root out of this equation and finally found out that the missing side AC is equal to the square root of 9, that's actually 3. The square root of 9 is 3, so AC equals to 4 units in its length. This is side AC, that is equal to 4 units in its length. So here AC equals to 5. This side AC equals to 3. AC equals to 3 units in its length. In the next step, we define the center of this circle. This point is point O. We also define the radius of this circle as X. In the next step, we join points O and B together by straight line. OB is the radius of this circle, that is equal to X. And because of the fact that the radius OB is 1 to point B, that is the point of tendency of tangent PB in this circle, and whenever radius is 1 to the point of tendency, then tangent PB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means this angle equals to 90 degrees according to rule 1. It is given as the question that PB is a tangent to this circle. So PB is as a tangent, it is absolutely a straight line. So if you focus on the upper side of the straight line PB at point C here, so here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of PB at point C, we have this angle that is right angle, plus this missing angle, in total must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. In the next step we did the construction, that is to say, from this point O, we draw perpendicular on AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O in AC. This point is point E. By doing this construction, we did the quadrilateral OECB. Inside quadrilateral OECB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral OECB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at its right angle plus its square. So we write quadrilateral OECB OECB is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle OECB, side OE must be equal to the opposite side BC. But BC is 1, therefore OE must be also equal to 1 unit in its length. Likewise, according to the sum rule, in the sum rectangle OECB, side OB must be equal to the opposite side EC. But OB is x, therefore EC must be also equal to x units in its length. What is the length of the missing line segment AE? AE equals to AC minus CC. Again, A equals to AC minus CC. So A equals to AC, that is 3, minus CC, that is x. So in total, A equals to 3 minus x units in its length. In the next step, we join points O and A together by side line. OA is the radius of this circle. That is equal to x. According to our definition. So in the next step, we copy the right triangle OAE in the new page and we implemented the Pythagoras theorem on this right triangle OAE. Actually, this is the right triangle OAE that according to the original drawing, according to the Pythagoras theorem, in this right triangle OAE, OA square, that is the square of the hypotenuse, is equal to AE square plus OE square. OA is x, therefore OA square is x square, and it is equal to AE square. AE is 3 minus x, therefore AE square is 3 minus x square, plus OE square. OE is 1, therefore OE square is 1 square, that is 1. So in total, we found out that x square equals to 3 minus x square plus 1. Here we open the brackets on this side of the equation, and we found out that x square equals to 3 minus x square. 3 minus x square is 3 square, that is 9, plus x square. Plus 2 times 3 times x, that is minus 6x plus 1. So here we have x square on both sides of the equation, so x square will get cancelled. After we cancel x square, on this side of the equation we have keep nothing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10, or 6x. So in total we found out that 0 equals to 10 or 6x. Here we added 6x to this equation and finally found out that 6x equals to 10. So here we divided this equation by 2 and finally found out that 6x over 2 is 3x and it is equals to 10 over 2, that is 5. So in total we found out that 3x equals to 5. Here we divided this equation by 3 and finally found out that x equals to 5 over 3 units in its length. That is to say the radius of this circle x equals to 5 over 3 units in its length. Our mission is to find out the area of this circle. Actually the area of any circle is equal to pi times the radius of the circle squared. And again, the area of any circle is equal to pi times the radius of the circle squared. And therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius square is x squared. And total we found out that the area of this circle is equal to pi x squared. X equals to 5 over 3, therefore x squared must be equal to 5 over 3 squared. So in total the area of our circle is equal to pi times 5 over 3 squared. So it is pi times 5 over 3 squared. 5 over 3 squared equals to 5 squared, that is 25, over 3 squared, that is 9. So in total we found out that the area of this circle is equals to either 25 pi over 9 square units, so in terms of numbers, the area of this circle is equal to 8.727 square units. So we finish with the first question, and the next step I presented to you the second question and we solved it. Our mission in the second question is to find out the area of the trapezoid ABCD. It is given as a question that AB equals to 16, AD equals to 17, BC equals to 25, and DC equals to 44. Our mission is to find out the area of this trapezoid ABCD. Actually, the area of any trapezoid is equal to the sum of its two parallel bases times the height over 2. Therefore, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases. The two parallel bases is AB and DC, and therefore the area of the trapezoid ABCD must be equal to AB plus DC, that is the sum of its two parallel bases, times the height, that is edge over 2. Okay, again, the area of the trapezoid ABCD must be equal to AB plus DC, that is the sum of its two parallel bases, times the height, that is edge, over 2. The height edge must create 90 degrees with the two parallel bases AB and DC. So, in order to find out the area of this trapezoid ABCD, we did a construction, that is to say from this point A, we drew perpendicular on DC. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in DC, this point is point E. We define the length of line segment DE as X. And we also define the length of side AE as H. AE is one side of the right triangle AD, but AE is equal to X is also the height of trapezoid ABCD. Why AE is the height? Because of the fact that AE is equal to X makes 90 degrees, creates 90 degrees with the base DC. Therefore AE that is equal to H is also the height of this trapezoid ABCD. In the next step, I copy the right triangle AED in a new page and implemented the Pythagoras theorem in this right triangle AED. Okay, this is the right triangle AED that I copied from the original drawing. According to the Pythagoras theorem, this right triangle AED, AD squared, that is the square of the hypotenuse, is equal to AE squared plus DE squared. Again, AD squared equals to AE squared plus DE squared. AD is 17, therefore AD squared is 17 squared, that is 289, and it is equal to AE squared. AE is 8, therefore AE squared is 8 squared plus DE squared. DE is X, therefore DE squared is X squared. So in total, according to equation 1, we actually found out that 289 equals to 8 squared plus X squared. In the next step, we did another construction, that is to say from this point B, we drew perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC, this point is point F. So here we can implement all 16. Why? Because of the fact that AB is parallel to DC. So those two angles, they are both located between the parallel lines AB and DC, and therefore they are both defined as an interangles. In addition, those two angles, they are both located on the right side of the straight line AE, and therefore they are also defined as one-sided angles. So in total, those two angles, they are both defined as one-sided interangles, and according to rule 16, the sum of two one-sided interangles is equal to 180 degrees. So this is the missing angle, that is angle BAE, plus this angle, that is the right angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 16. So repeat again. The missing angle BAE plus the right angle in total must be equal to 180 degrees according to rule 16. Why? Because of the fact that those two angles, they are both defined one-sided interangles, and according to rule 16, the sum of two one-sided interangles is equal to 180 degrees. So here we subtracted 90 degrees from this equation, and finally found out that the size of the missing angle BA is equal to 180 degrees minus 90 degrees is 90 degrees. So the size of this missing angle BAE is equal to 90 degrees. So here, what is actually in quadrilateral ABFE, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. So which angles? So therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ABFE we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at the right angle, if not a square. So we relate to this quadrilateral ABFE is right angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle ABFE, side AB must be equal to the opposite side FE. But AB is 16, therefore FE must be also equal to 16 units in its length. Likewise, according to the same rule, in the same rectangle ABFE, side AE must be equal to the opposite side FB. But AE is X, therefore FB must be also equal to X. What is the length of the line 7, the missing line 7 FC? For the drawing, it is very easy to see that FC in total equals to DC minus DE minus EF. Again, FC equals to DC minus DE minus EF. So FC equals to DC, that is 44, minus DE, that is X, minus EF, that is 16. So in total, FC equals to 44 minus 16, that is 28, minus X. So FC equals to 28 minus X. In the next step, according to the right triangle BFC in the new page, and we implemented the Pythagoras theorem on this right triangle BFC. Okay, this is the right triangle BFC that according to the original drawing, according to the Pythagoras theorem. In this right triangle BFC, BC squared, that is the square of the hypotenuse, is equal to BF squared plus FC squared. The hypotenuse BC is 25, therefore BC squared is 25 squared, that is 625, and it is equals to BF squared. BF is H, therefore BF squared is H squared, plus FC squared. FC is 28 minus X, therefore FC squared is 28 minus X squared. So in total, we should find out that according to this equation 2, 625 equals to H squared plus 28 minus X squared. Here we open the brackets on this side of the equation, and we actually found out that 625 equals to H squared plus 28 minus X squared. 28 minus X squared equals to 28 squared, that is 874, plus X squared minus 2 times 28 minus X, that is minus 56X. So in total, we found out that according to equation 2, 625 equals to H squared plus 874 plus X squared minus 56X. Here we subtract 625 from this equation 2. So in this side of the equation we have nothing, that is to say 0. On the other side of the equation we have H squared plus X squared minus 56X. And 874 minus 625 is 159. So here we have H squared plus X squared. But H squared plus X squared according to equation 1 is 289. So we can substitute H squared plus X squared by 289. We did it. And we should found out that according to equation 2, 0 equals to H squared plus X squared, that is 289, minus 56X plus 159. So here we added 56X to this equation 2, and finally found out that 0 plus 56X is 56X, and this equals to 289 plus 159 is 448. So in total we found out that according to this equation 2, 56X equals to 448. Here we divided this equation by 56 and finally found out that X equals to 448 over 56. 448 over 56 is 8. So X equals to 8 units in its length. The next step, we return back to equation 1. According to equation 1, H squared plus X squared is equal to 289. We have already found out that X equals to 8. If X equals to 8, it means that X squared equals to H squared, that is 64. So we can substitute X squared in this equation 1 by 64. We did it, and we should found out that according to equation 1, H squared plus X squared, that is 64, is equal to 289. Here we subtracted 64 from this equation 1, and finally found out that H squared equals to 289 or 64 is 225. So H squared equals to 225 according to equation 1. Here we took a root from this equation, and actually found out that H, that is the height of trapezoid ABCD, is equal to the square root of 225. The square root of 225 is 15. So the height of trapezoid ABCD, H, is equal to 15 units. Our mission is to find out the area of trapezoid ABCD. We already found out that the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC, times the height, that is H, over 2. AB is 16, DC is 44, H is 15 divided by 2. 16 plus 44 is 60, so in total this expression equals to 60 times 15 over 2. 60 over 2 is 30, so in total this expression is equal to 30 times 15. 30 times 15 is 450. So in conclusion, what we found out, the area of this trapezoid ABCD is equal to 450 square units. Okay, thank you very much.